Hello, welcome to another of my videos where I work through and explain A-level Physics multi-choice questions. If you want to try to answer this question yourself, pause the video now. If you got the answer D, well done. If you'd like to hear my explanation of how I found the answer, please continue watching. So, this graph shows the variation of displacement D with time t for a particle moving with simple harmonic motion of period large T, capital T, which graph shows the variation of kinetic energy of the particle with time. So what we're talking about here is we're talking about either a spring mass, and if we put on there its equilibrium position, it's going to oscillate with a displacement above and below its equilibrium position. It's actually travelling at its fastest when the displacement is d. So at that point there is when the spring is travelling its fastest. When it gets to its maximum positive or its maximum negative displacement, its velocity is actually 0. So let's have a look at what that would look like on the graph. So I'm looking for when the displacement is 0 to get the maximum velocity. And of course, the kinetic energy is given by a half mv squared. So when I get the maximum velocity, I'm going to get the maximum kinetic energy. So displacement 0, that's when I get the maximum velocity. So that's when I get my maximum kinetic energy. When the displacement is at a maximum, the mass actually stops moving, velocity is 0, so the kinetic energy is 0. Again, displacement 0, at the rest point, I get its maximum velocity, therefore maximum kinetic energy. Now you can't have a negative energy. You can only have a positive energy. It doesn't matter whether it's moving upwards or downwards, it's still going to increase in a positive way the kinetic energy it's got. Again, look at this point, that's a maximum negative displacement. Whether it's negative or positive displacement, the velocity is 0, therefore the kinetic energy is 0. Once more, 0 displacement, maximum velocity, maximum energy. So we're looking for a graph of something like that shape, which is D. If you found this video useful, please press the like button, or comments will be welcome, particularly if you have a question you'd like me to go through. And I hope you'll share and watch more of these videos in the series.